We have 15 minutes to get you prepared for what will hit you out there. Namely, that you have to dig into data. This course is about data analysis, statistics and data analysis. Intelligent, looking at data in an intelligent way. The way we're going to do it in practice is by using a software called R. The R will be very good of producing something that we will also continuously do in this course, but which is not in a way part of the course. So I am not going to spend time in my course to teach you to do really brilliant graphics. I'll teach you a little bit. We come up with one here that is linked very closely to what I've taught you now. But anyway, it is still very important, and you know communication generally is very, very important when you're out there, when you communicate your results. So that will maintain in your career to be very important for you. I'm not trying to teach you in this course, but I'm not saying it's not important. I'm trying to teach you the statistics behind some of the nice graphics. We should still, of course, think about nice graphics. R is one way to do nice graphics. Other softwares can do nice graphics also. So there are some plots here that I'm going to show you. Now I'm going to show those plots to you as a part of my R introduction, because that's more natural, I find. So we are talking about the software R now, that you will be using throughout the course. It will be necessary to know and be able to see results. For the exam, you must use it. I would like to emphasize again, please read the book, right? There are so many good things in the book that I haven't the time to say here. I only have 2 by 45 minutes. If I want, I could speak for the quadruple time on the same thing, but probably it's good that I'm not. But then you go read instead. R cannot substitute brain activity. It's a fantastic tool, but it has no brain whatsoever. You have to be the brain there. And we expect of you, I expect of you, that you can use your brain. Don't expect, actually today is maybe slightly different. Today you can maybe solve many things just by jumping directly into R and do it. Generally the exercises I'm going to give you, and also at the exam, you cannot, I'll try to convince you, you cannot just sit with your computer in front of you, start R, and then solve them. If you can, I'm amazed. You have a brain activity beyond what I could ever imagine. I think some of you for sure have, for no guy like me. But I have no idea how you should be able to solve those exercises if you not use a little bit of pen and paper. This is partly math, actually. There are some details and some formulas that I want you to know about. And you cannot just go through this course by jumping directly into R and say, compute the mean, compute the median. It's part of it, but not all of it. I'm emphasizing this, right? Please use your brain. I recommend you. If you can do it electronically, pen and paper, then fine with me. I mean, that's not the point. The point is you need to do a little bit of thinking and working sometimes before you solve things in R. You have to install the R, and the RStudio is recommended. So you find the link, you Google R and you install it, it's open source. The RStudio is a nice way of running the R. So when you have installed R and RStudio, you just start the RStudio and then you're up and running, right? But you install both. But then when you run, RStudio uses the R that you have on your computer in a nicer way. I'm going to give you a short intro to what we can do. If you haven't met it before, it's much like MATLAB in the basic setting, but in many ways extremely nicer than MATLAB. And when it comes to the price of it, it is infinitely nicer than MATLAB, right? And I can assure you that this is almost a computational revolution going on out there with this R stuff and similar things growing around it now, that everyone out there in the whole globe have access to the R computing environment. And statisticians and developers in the entire world are adding packages as we speak. So there are thousands and thousands and thousands of things implemented for free for everyone to use out there. The smallest company in Burkina Faso can sit and do advanced predictions of whatever based on our computing. Everyone can use it. And people are using it more and more, also in established industries. Anyway, go read it, the introduction in our e-note. It will be used throughout the course in an integrated way. You will realize, especially next time when we meet and start talking about probability theory, that we need to spend a couple of weeks on the probability. You will see that we use it in two different ways. We use it as a pedagogical tool to show you some things, because it's really nice to do simulations, can show you those things. And then, of course, for you, it's a data analysis tool. It's a graphics tool, it's a data analysis tool, it's a computing tool. I'm going to show you just a few slides, because here it looks a bit nicer than when I actually jump into R, but then in a sec I will jump into R, and then we'll see what happens. Maybe I should actually, before we do it, I should just, if you haven't been there before, I have the RStudio up and running here. This is how it would hit you in the face when you started. I sort of tested a little bit before. You can just forget about that. Let's go to the top here. I share these R files with you, right? If you've seen on the material, there will be a number of files called .r. These are just plain raw text files that when you have installed RStudio, it will recognize the .r typically, or you can ask it to, such that these are script files that will open in a script window as part of the RStudio, right? So it's running this way. It's a script-based, like MATLAB. It's a script-based tool. There are ways to run R applications in a nicer, shiny, something called Shiny. You can run it as a nice and shiny web applications if you want, but that's not for us now. We should have a look at the detail here. So let's start doing advanced computing stuff in RStudio using R. For instance, let's add the two numbers, 2 and 3. 3, 2, 1. I missed it. Here we go, it's 5. There are some shortcuts to go source line by line. Control Enter, you can like that, run. Here I assign the value 3 to y, so now I have a variable y that has the number 3 in it. Here I assign the list, I concatenate, I make a list of numbers, I make a vector, 1, 4, 6, 2 into x. Sorry for the naiveness here for many of you. So I have this list of numbers, x. Here I assign the values 1 to 10. If I didn't write, I do the shortcut, I run line by line, right? I have it up there, and then you get the result in the console down there. There's a nice little thing that we use a lot for plotting and other things. I can also define the sequence between 0 and 1 with steps of 0.1. So I could define a sequence like that. Let's see what happens. As you see, I can also mark several lines to source to submit them simultaneously. So here's the sequence from 0 to 1 by steps of 0.1. That's a little thing that can be used in many plottings, as said. Here we come already to some of the funny stuff. Let's see if I, within 2 minutes, can work with your data. This is now where it probably will break down. Let's see. Let's finish. Get reports. Download. So now it already, here we are, waiting. Yeah, it broke down on me. That's what I thought. Let's see. Give myself 1 more minute. No. I will look at your data next time. That's what I expected. So it's good that I have the height data from the book already ready. So we put it in the X. We can see that there are 10 observations, we can of course compute the mean and the median. These are inbuilt functions in R, just to make that point, right? The variance and the standard deviation is also there. The quantile function is there. To get the definition of the book, we have to put type equal 2. I told you there are different types of quantiles out there. Histogram, now I want to get to some of the plots. You can read about the histogram. You can read about the relative histogram. You can read about the empirical distribution, where I basically write the numbers and give 1/10 to show how is it really distributed across the scale. And then one thing I just want to spend the last 5 minutes sharing with you, the box plot. The box plot, and this is where I think I should go to my slide, because probably I prepared a nice way of showing you. Here we are. The box plot, and there are some options, and we don't, I'm not going to harass you with knowing about options in our functions, at least not ridiculous options. There are also always some nice defaults, or then you can see some other options with the material I share with you. The point is, the box plot basically gives you the quantile or the quartile information like I've defined to you. It gives you the maximum. What is the maximum? That is the 100% percentile, the one quantile. It gives the median, it gives the minimum, and then it gives these two. So the box there is the middle 50% of the data. So the box contains the middle 50% of the data, and the range of the box is also called IQR. You can read about that also. The box plot comes in two versions. It comes in the traditional one, and it comes as a modified one. Actually, this is where pedagogically it might become confusing, because the R chooses the modified one as the default. I started out by sharing the classic one. In the modified box plot, there is an inbuilt search for extremeness of observations. I'll not bore you with the exact definition of it here. You can read about it. If individual observations are too far away from the majority of observations, it will be highlighted explicitly, like in this case. So here I had can you see that? I had the basketball guy added to my data here. So when the basketball guy came in as the sixth observation, he was highlighted as an individual outlier here, right? By the default box plot in R, which is the so-called modified box plot. You can find the exact definitions in the text. This is as much as I plan to introduce R to you. This is a learning by doing thing. You should go do it now, right? The next 2 weeks we do probability, because we need the probability to be real intelligent. And then we get back to the numbers after that. Using the probability, looking at the numbers, getting to the real stuff. That's the plan of the course. So enjoy. I'll see you out there.